Today, Assistant Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. We study the basic concept of mechanics for the further applications of the mechanics. Basic concepts such as velocity from the MSc first semester first subject mechanics, and post unit is Lagrange's formulations. And Lagrange's formulations, we study basic concept first velocity. Velocity, what is velocity? The velocity is the change of displacement with respect to time t. That is, let a particle be moving along any path with respect to the fixed point O. If r bar is the position vector, then the velocity of the particle is defined as the time or rate of change of position vector, that is v bar is equal to r bar dot, where dot denotes the derivatives with respect to time t. If the r bar is equal to xi plus yj plus zk in position vector, then velocity of the particle v bar is equal to r bar dot is equal to xi dot plus yi dot plus zi dot zk dot, where x dot, y dot, zk dot, z dot are called the components of the velocity along the coordinate axis. Next one, linear momentum. The linear momentum of a particle is defined as the product of mass of the particle and its velocity, product of mass m and its velocity v. It is a vector quantity and it is denoted by p bar, small p bar, that is p bar is equal to m v bar. Velocity is again vector quantity and mass is scalar quantity. The direction of momentum is along the same direction of the velocity. In terms of linear momentum of the particle, the equation of motion is given by f bar is equal to p bar dot. Equation of motion is given by, in terms of force, f bar is equal to p bar dot. P bar, what is dp bar by dt. P bar, change of linear momentum with respect to time t. Next one, angular momentum. The angular momentum of a particle about any fixed point O as the origin is defined as r bar multiply p bar. It is a vector quantity and it is denoted by L bar. Thus, L bar is equal to r bar multiply p bar. Angular momentum is perpendicular to both the position vector and the linear momentum of the particle. Next one, torques. Q or motion of a force. Torque. The time rate of change of angular momentum L bar is defined as a torque and it is denoted by N bar. N bar is equal to dl bar dt or d by dt of r bar multiply p bar, d by dt of r bar multiply m v bar, and r bar dot multiply p m r bar plus r bar multiply f bar, and n bar is equal to dl bar dt is equal to r bar multiply f bar. Next one, equation of motion and conservation theorems for particle. Consider particle of mass m whose position vector of the with respect to the some fixed point is r bar. If f bar is a force applied on the particle, then the equation of motions of the particle is given by Newton's second law of motion. F bar is equal to dp bar dt, where p bar is equal to m dr by dt is equal to m r bar dot, and is the linear momentum of the particle. The force is defined as F bar is equal to mass into acceleration. F bar is equal to ma bar. Therefore, d2r bar dt square is equal to a, and integrating dr bar dt is equal to at plus c, where c is the constant of integration and is to be determined. Now applying the initial condition when r dt is equal to 0, r is equal to 0, therefore dt by dt is equal to dr by dt is equal to u bar, initial velocity. Therefore c is equal to initial velocity u bar. Therefore v is equal to a plus u plus at. Thus equation of the will determine the velocity of the particle at any time t, integrating r bar is equal to ut plus 1 upon t I t square plus c1, where c1 is the constant of integration at t is equal to 0, r is equal to 0, c1 is equal to 0. Therefore r is equal to at plus 1 upon t at square. uh, this equation gives the distance covered by the particle at any time t, and one can combine equation this. Use v square is equal to u square plus twice ar. This equation determines the velocity of the particle at a given distance, and equation v square is equal to u square plus 2ar. R is equal to v is equal to ut plus 1 upon 2 at square. R is equal to ut plus v is equal to u plus at are the algebraic equation of the motions and derived from the equation 1, namely namely F bar is equal to P bar dot. This is the differential equation of motions, and it follows the equation 7, F bar is equal to P bar dot, that if the applied force is 0, then the linear momentum of the particle is conserved, that is P bar dot is equal to 0, P is equal to 0. Now, equation of motion of system of a particle. Consider a system of particle of masses m1, m2 dot 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 mn having positions vectors ri bar I is equal to 1 2 3 dot 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 n related to an arbitrary fixed point. Any particle of this force system will experience two types of forces: external forces and internal forces. External forces Fi bar and Fij bar internal. Thus, the force acting on the ith particle Fi bar is equal to Fi bar plus Fji bar internal. Fji bar internal is the total internal force acting on the ith particle due to the interaction of all the n minus 1 particle of the system. Thus, the equation of motion of the ith particle is given by Fi bar plus Fj internal is equal to P by Pi dot. The equation of motion of whole system is obtained by summing over I. The equation of 1 we get Fi plus Fig internal is equal to Pi dot. We write it as Fi plus Fji internal is equal to Pi dot. The terms Fi Fji internal represents the vector sum of the particle interaction forces due to the presence of remaining n minus 1 particle. Uh, However, there is no self-interacting force. Hence, Fji bar is equal to 0 for I is equal to j. Also, the internal force obey the Newton's third law of motions, that is the action of one particle on the another on the other is equal but opposite to the action of second on the first. This implies the mutual interaction between the ith and jth particle are equal and opposite. that is Fi Fj internal is equal to minus Fij internal. Therefore Fj internal is equal to 0. Therefore Fj internal Fi is equal to P bar dot. Therefore Fi bar is equal to P bar dot, where P is the total momentum of the particle. P is equal to P dot is the total external force acting on the system. This is our required proof.